Last video we crunched through this page of definitions and this extra page of definitions. Let's use these definitions in a bunch of examples. So for all of these, let's figure out, are the sets bounded, are the sets closed, or open? Okay, so this one right here, set of all x, y in the plane such that x squared plus y squared is less than or equal to 1. So this is a filled in circle, a disk here. Is it closed? Yes. It contains its entire boundary, so this is closed. And it's not open because the points on the boundary are not interior points, so it doesn't consist entirely of interior points. Is it bounded? Yes, it's bounded because I can draw a bigger circle around it. So this is closed and bounded. In section 14.7, we're going to make a big deal about closed and bounded sets. Second here, part B, x and y is in R squared such that x is greater than or equal to 0. Okay, so it's this entire half plane here, but the fact that we all have x is greater than or equal to 0 means that we include the y-axis here. Okay, is it closed? Well, the y-axis is the boundary. This is the boundary here. Is the y-axis, and it contains the entire y-axis, so this is closed. So that's good. It's not open. Points on the y-axis are not in the interior, so it's not open. Is it bounded? Well, this is going off to infinity, this is going off to infinity, this is going off to infinity. I can't draw a circle big enough, to encapsulate, everything that we have here, because it's going off to infinity, so this is unbounded. So this is closed and bounded, this is closed but unbounded. Okay, part C here, x, y is in R squared. X, y is in the plane such that x squared plus y squared is strictly less than 1. Okay, so the idea here now is that this is a filled in circle here. It's a filled in circle that does not contain the boundary. It doesn't contain x squared plus y squared is equal to 1. X squared plus y squared needs to be strictly less than 1. So points, this is on the boundary. That's not in the set. And so what do we see here? This is going to be not closed, but it is going to be open because it just is the interior of this circle. So this is not closed, but it's open. And is it bounded? Yes, we can draw a big circle around it. So this is an open bounded set. Okay, part D. X, y is in R squared such that x is positive and y is positive. So that's going to be first quadrant here, but we need to, omit or, exclude, I guess we could say here. We are excluding the positive y-axis. We're excluding the positive x-axis because x must be strictly positive, y must be strictly positive. So it's not closed because this point is on the boundary of our set, but this is not in the set itself, so it's not closed. Is it open? Yeah, so everything here, at any point that you can find here, is in the interior. So this is open. Is it bounded? No, there's no way that we can This is going off to infinity. There's no way we can draw a big enough circle to encapsulate everything here. So this is open, unbounded. Okay, next one here. xy is in R squared such that x is between 1 and 5 inclusive, y is between 4 and 10 inclusive. So 1, 5, 4, 10. This is not to scale here. Doesn't really matter. It's going to be this rectangle. And we are including, that all four sides here because of the inequalities here. So this is going to be closed because this is the boundary and all of the boundary is in the set. And the boundary, like that point right there, is not an interior point. So this is closed, but not open. And what else can we say here? Is it bounded? Yes, I just drew a circle around it. So this is closed and bounded. Closed and bounded, as we're going to see in section 14.7, is going to be the best case that we can do. Finally, this last one here, xy is in R squared, x is positive, x squared plus y squared is less than or equal to 10. So this is a circle. This right here is a circle of radius 10. But we're only going to deal with x is positive. Okay, so we're including, so this is, sorry, I said radius 10. I should have said radius 10, square root of 10. And so over here, these points are going to be included. These points, there's a less than or equal to here. So these points are going to be included. But these points here are not in our set. X needs to be strictly positive. So this is going to be neither closed nor open. Because this right here, the y-axis is part of the boundary. Doesn't include the y-axis. But these points here on the boundary, they're not in the interior. Like any circle we draw around there is going to go outside of the set. So it's neither closed nor open. Draw a circle around it. This is a bounded set. Okay, so that's 6 examples. Hopefully this helps shed some light as to how all of this stuff works.